So now that we have all of those definitions, we need to take a minute to really look at them and make sure we understand them. So when we look at this picture, whoops, right here, we want to decide what lines are parallel. So when we're looking at parallel lines, typically we're going to see those nice little triangles, little arrows, and so we know that P is parallel to K. That's important because that sets up the first part of our parallel line in transversal relationships. When we're looking for the transversal, that is the line that will cut across our parallels, and so that is W. So now we are going to start talking about our specific pairs. I'll erase my notes here for you guys, sorry. So same side, interior, one pair. So if we are on the same side of our transversal, so we're looking at 4, 3, 2, and 1 are on the same side, but we have to be on the inside of the parallel lines. That leaves us with 2 and 3. Or if we go to the other side, so 2 and 3, and if we look over here, 6 and 7 are also same side interior. If we want to think about alternate exterior angles, get rid of our markings. So now we are on alternate sides of this transversal, which means opposite, and we are going to be outside of these parallel lines. So we are looking at these outside angles. And if we have to be alternate, we're talking about 4 and 8, or we're talking about 1 and 5. So it's really nice that these angle names tell us exactly what we're looking for. So let's think about this next group. Get all of our markings erased here so we can pay attention to what we need to. So now we are looking for alternate interior. So we are still going to be on opposite sides of this transversal, alternate, but this time we want to be inside of our parallel lines, on the inside of them. So when you think about what our choices are there, clearly opposite inside are 3 and 7, and 6 and 2. If we want to talk about the next kind, which are corresponding, now if things correspond, it means they kind of match up. And so if we think about where these angles are going to match up, let's highlight our transversal again, because that just helps us see what we're doing. So here's our transversal, and then here's our parallel lines. So if I want to look for angles that correspond in position, 4 is above and to the left. Well, who else is above the parallel line and to the left? 2 is. So 4 and 2 are corresponding. Who is below and to the left? Below and to the left, well, that's 3 and 1. They are in a corresponding position relative to the parallel lines and the transversals. So we have 2 more pair. So if we go to this side of the transversal and we go above our parallel lines, we are looking at 5, and 7. And if we go below and to the right, we're looking at 6 and 8 as our corresponding angles. This whole page and these definitions are absolutely something that you really need to know and need to know inside out and upside down. So we're going to continue looking and naming angle pairs. So 1 and 5. If I look at 1 and 5, they are both outside of the parallel lines and on opposite sides of the transversal, so that makes them alternate exterior angles. If I look at 3 and 7, here's 3, here's 7, they are on the inside of the parallel lines on opposite sides of the transversal, so that makes them alternate exterior angles. If we look at 2 and 4, 2 and 4 are both to the left of the transversal. They're on the same side, hint, hint, of the transversal. They are both above the parallel line, so they correspond in position. So these are corresponding angles. If we look at 4 and 6, 4 is here, and 6, that's one of our old angle pairs because they make vertical, they make V's, and so those are vertical angles. Now I throw those in there because they exist, but they don't have anything to do with our parallel lines. And so as we move forward to what proves parallel lines, you're going to want to be careful to not get tricked by vertical angles. Clean up our picture. And if we look at 4 and 5, 4 and 5, again, notice they are only formed by 2 lines, not 3, which is what we need for a pair of parallels and a transversal. Notice K is not even a part of this. This is also one of our old sets because these are a linear pair. These two are going to be the trick questions on the test because they don't have anything to do with parallel lines. So we just want to remember that old information will follow through with us. So go ahead and tune into the next video for the rest of the lesson.